All right. Now, so your second test is gonna be on Wednesday, not Monday. It's gonna be on Wednesday, the October 13th. Okay. So it'll be on Wednesday, October 13th. It will consist of the same section 4344, 51 to 55, and 9.1. Okay. So it's a change of date. It's going to be the same time from 2 to 3:30. And then I do have a review at 1:30 to 2 o'clock. No, same thing as last time. And I will send you guys the test review sometimes today or tomorrow. Okay. Uh, someone asked me some question about 5.3. Is that Kelvin or Nukin?
Yeah, I was wondering if the notes for 5.3 are going to be on the exam too. Like, are we going to be able to use the notes for the properties of logarithms?
No, actually, the problem of logs, you need to know that. So today's section is going to 5.3. So the only thing I provide to you in your exam is the chapter 4, the conic section. That's the only part that I will provide to you. The rest of it, the chapter 5, the properties of logs and the transformation, you know, the up, down, left, right, won't be provided in your test. So make sure you know, understand it. And today we will go over the properties of log here. Does anyone have any homework questions or any questions for me? Does anyone have any questions for me? You guys can see my screen, right? Just my screen. Anyone have any questions for me? So again, test 2 is on Wednesday, October 13. It's from 2 p.m. to 3:30 p.m. And then as usual, we got the 30 minutes before we got a review. So from 1:30 to 2 o'clock is a review. And it's going to be in CLA 116. And if that classroom is taken by someone else, you know, like last time, make sure you check around it. Maybe I am right across the hall, CLA 123. So make sure if you find I'm not around the classroom, I might be next door or across from it. And if you hear my voice, just walk in because it is your class. I don't teach a lot in school on campus. So so if you hear my voice, that's your class. Okay, so just walk in. Don't be shy. Okay. So hopefully you will come to my review section at 1:30. So this is in CLA 116. Okay. Next we're going to talk about is homework question. Does anyone here have any homework questions on your let me see what is homework is due. Anyone have any homework questions? Anyone have any questions for me? So I will definitely move your homework a little bit so so you won't it'll be not so cramped out. Let me see what's your homework here. So yeah, I'll move them around. So 5.1, 5.2, 5.3 is due on this coming Wednesday. We did 5.1 and 5.2 on last week. So today we'll go on the properties of log on 5.3. And then 5.4 we're gonna do it on Wednesday. So and then 5.591 we do it on Monday. Okay, so the schedule here is today is Monday. So we will do 5.3. And then 5.1, 5.2, 5.3 homework is due on Wednesday. And then this is going to be on Tuesday. So it's not going to due on Sunday here. So because your test date is moved. And then on Wednesday, we will talk about 5.4. And then on the following Monday, we will do 5.5 and 9.1. 9.1 is very easy. So that's why it will be really quick. And then on Wednesday, you will get your test 2 here. So this is your next 2 weeks of scheduling here. And 5.4, 5.5, and 9.1, your homework is due on Tuesday, not Sunday, the Tuesday, the day before your test, which is the 12th, October 12th. okay, by midnight. So I will change the due date here. That's not going to be due on Sunday the 10th. It will be due on the 12th by midnight. Okay. Anyone has clear with this? Anyone have any questions with the scheduling here for this coming week? Anyone have any questions for me before we start with our 5.3 today? Okay, that's already quiet. So as what Calvin brought out, yeah, 5.3, you got a lot of quite a few properties of log here. This is 5.3. Unfortunately, this is not provided in your test here, so you need to know your properties here. So and I will tell you what is it used for. Okay. The first property is called a change of base formula property. This is used. This change of base property is used when you want to calculate with using your calculator with different base. Okay, so this change of base formula is used if you want you to use your calculator to figure out what is log 3, like question number 1 and 2, like log 1/5 and log 3, because our calculator only have base 10 log 10 and ln natural log. So it doesn't have a log base 3 or log base 5 or log base 2. So in order for us to have to get a different base, so we have to use a change of base formula. What happened is this is a formula that very important and you need to memorize, or you need to know this. Not too difficult. If you want to change it to base 10, then log ax is log x over log a. If you wanted to change it into base e, which is ln in this case, log ax is ln x over by ln a. So this is used a lot if you want to convert it to a different base, and it's used a lot when we want to figure out the calculator piece here. Okay, so example is like question number 1 here. You have to rewrite log 1/5 log 1/5x as a ratio of common log and b natural log. So common log means that it is base 10. Okay, so you will get these kind of questions in my test next week. So when the class for common log is base 10, like this is common log. Okay, and if they want you to write it in a natural log will be base is ln, base e. Okay, so so when the question asks you to write in the common log, so make sure that the argument, the x, will go to the top, the one, and the base will go to the denominator. So can someone tell me how you write log 1/5 x in a common log? Henry, Nukid?
Log x over log 1/5.
Yep, so it's log x over log 1/5. How do you write this in a natural log? So
Same thing with just ln.
yep, ln x over by ln 1/5. So this is the reason why is we want to change, we call it the change to base. So make sure you guys know this, and no matter if because this is x, we cannot use your calculator to do this. But if it's a number like number 2, they got a different number here, then we can use your calculator to do it. So how do we evaluate question 2 here is you can either change this into a common log, base 10, or you can change it to a natural log. So no matter which one you pick, you will still get the same answer. So go ahead. I want you guys to do question 2 using your calculator. How you change? How do you evaluate log 3.05? Let's do with a natural log first, and then the common log first, and then after that we'll do a natural log and see if your answer is the same or not. And I want it in a 3 decimal places here. So the first one will be log. Anyone know how to change your base on the natural on the common log for number 2? Log 3.015. Gamal.
Would it be log 0.015 divided by log 3?
You got a calculator with you, Gamal?
Yeah.
Yep. Can you use your calculator and figure out what is that number is in 3 decimal place? You got this.
Yep.
This
That's what I
number,
got.
3.8227. How much an answer in 3 decimal place? Negative
3.823.
Right, and try to do this again using the natural log, ln. ln 0.015 over by ln 3. Do you guys get the same answer as using the common log one?
Yep.
Yes. So as what I mentioned early on, so it doesn't matter which one you pick, but only thing common mistake students do is they got these two mixed up, means that they put the base on the top and they put the argument at the bottom. That means the 0.015 and 3 got switched around. This is common question students made mistake in my test. Do not mix those two around because you will get totally different answers. It means it's wrong. So make sure you guys understand it is the x, the argument goes on top, the base goes to the denominator. Questions using this change of base formula. It's very straightforward. It's not that difficult actually. And then we got 3 other properties of log here. The first property is called the product property. So product means you multiply. If you multiply log AU times V, it's the same thing as log AU plus log AV. This is the same as your exponents. So if you remember last time in your algebra 1, we call the product property of the exponents a to the power of m times a to the power of n. Do you guys know what happens when you multiply? What happens to your power? Anyone?
You add them?
You add them, yep. So this is very similar. This is exponents. Now it's log, so it's the same thing. Log AU times V is log AU plus log AV. Do you remember last time when we do exponents, what happens when we divide them? Like AM.
You subtract.
You subtract. So this is the same thing for log here for the quotient. Quotient means it's division. If you divide log AU over V, is a log AU minus log AV. Okay. Now, don't forget that this kind of property is not one way, it goes both ways. It means it can go from the left-hand side to the right-hand side. So if you go from the left-hand side to the right-hand side, you are, so if you go from left to right, we call this as expanding. Okay, so why it's called expanding when you go from left to right is because you got one log on the left, and then when you go to the right, you got 2 logs. You try to expand it, so make it bigger. Okay, but you can also go from right to left. If you go right to left, if you read backwards, we are not expanding, we are condensing it into single log. So when you guys read the question, they will ask us like expanding the expression. So if a question asks us to expand, then you have to read it from left to right. If they want you to condense the expression into a single log, a single quantity, then we will read this right to left. So make sure you guys, I will use the same type of expression. I want you to expand it, or I want you to condense it. So expand left to right, from left to right. If I want to condense, you read right to left. So the next one that we have is a power property. So power property is where you have a power, and that power you can bring it to the front. Okay, as long as you have a log in the front there, log ax to the power of n is equivalent to n log ax. So this power property is used when you have n on the power, and you can always bring it the n up front. So these are the three very important properties. And do not forget that we also have additional properties that you learn in 5.2. So if you remember on 5.2, we have some property for log. The first one, this is what we did last week. Log A1 is 0, log AA1, log AA is 1, log AAX is x. This is the one that we use a lot. So this is additional properties of log on top of what you learn in today's class on 5.3. Okay. There's one important thing about this is if you have log AU plus V, log AU plus V is not the same thing as log AU plus log AV. So a lot of students think this is your product property. No, if you have U plus V, you cannot distribute your log. So that's what a lot of students do. What is actually log AU plus V? The answer will be log AU plus V. We cannot, there's no formula or no properties of the log for this case. So this is a common mistake students do in my test or homework is they distribute a log. Same thing happens to exponents. If you remember exponents, we multiply, we add, we divide, we subtract. But when you have addition, we don't have formulas for this. This is not the same as am plus n. Okay, this is not the same. So what happens to this is the same as him. So there is no formula for addition or subtraction. Same thing for log here. So we don't distribute the u and v in this case. Okay, so this is a lot of students do that in your homework or in your test. They will get it wrong. Okay. So like question number 3, 4, 5, 6 here, you have to evaluate this without using a calculator. So can someone tell me what is the log 5 1 over 125? Are we using these three properties of log that we learned today for number 3, or are we using the one that we did last week? One of these three. So which one are we using for this case? Quite a lot of that's 6 properties actually.
We're using the quotient property.
We can use the quotient property, but the best way for us, we can use a quotient property, but the best one is we're gonna use is the number 3 on the other property that you learned in 5.2, where you want to make your base and your argument the same, then you get x. Why I'm saying that for this question here is because can you write 125 in a base of 5? Can you write 125 in the base of 5? So this will be what? 5 to the power of what?
3.
3.
Not 3, because this is 1 over. So it should be what?
-3.
-3, right? So this, let me rewrite so it become nicer here. Some of you will be like, what's going on here? So I'm gonna rewrite this so that you guys get a nicer. So you will look something like this one. So this is number 3. Log 5 1 over 125 is written down as log 5 to the power of -3. And since the argument and the base is the same, you can cancel out. So your answer in this case is what? Your answer is -3. You can use number 2 here. You just make it longer. So you can make it that way. So you can do log 5, 1. When you divide, we subtract. So we minus log 5, 125. And you can do that way. You will still get back the same answer. Does anyone know what is log 5, 1 is? Without using a calculator.
0.
0. And what happens to this log 5, 125? You need to change this back to 5 to the power of 3. And then we can use the power property where you can bring down this 3 to the front. If you want to use the quotient and the power property here. So what you have in this case will be 0. This is a longer word, right? I told it's a bit more difficult. It's you still get the same answer. So you get 3 log 5, 5. And log 5, 5 is actually 1. So when you multiply this, you will end up with what? -3. So -3 times 1 is negative. So this is a way. So there are that quicker way like this way, which I showed to. I rather want you to do the quicker way, or you can do the longer way, which is the one that I'm just using the property. So again, for me in the test, doesn't matter what way you do, your answer is still going to be the same. I will accept it. Okay, so there are multiple ways to do these kind of questions. As long as you take the long way or the shortcut or whatever way you want to do, as long as you use the property correctly, I will give you the points. How about question number 4? Log 3 -27. Does anyone know what do we do for this question 4 here? Anyone? Me? Henry? Yes.
Could you change it to -3 cubed?
Can we change -27 to 3 cubed? Is this two the same thing? No, this is not the same thing. Do I mention to you guys what happens if your argument is negative? Anyone remember that? What happens if your argument is negative? Yes, Nukin?
Is it 3 to the power of 1/3?
No. If you have 1 over like that, then yes, then it's this fellow. What do I say last time when you do log of a negative number? What'd you get? Pick out your calculator. Do log or ln, put a negative argument, -3, whatever number you want to put in. What do you get?
Error.
Error. What's error means? Yep, you get error.
No answers.
Yep. So for us is what? DNE does not exist. Okay. So do not forget that log for any negative number in here is DNE. How about log a negative and log 0? What do you get? You also get what?
Error.
Error. Yes. So as I mentioned to you guys before on our last week class, that your argument must be always what? Positive. Yep, if you get negative or 0, you get error, or in our case, does not exist. And so make sure you guys understand like question number 4 here, where you see negative or 0 in your argument, automatically does not exist. Okay. How about question 5? Log 42 plus log 32. Which one are we using for this case? Product. Are we looking from the left to right, expanding, or are we condensing right to left? So which one are we looking at? Left to right or right to left? So since this is addition, so we're gonna go for the right to left. We are condensing it. So when you have an addition, what do you do when you condense this? So you have the log 4, and then you multiply these two up together. So it's 2 times 32. Does anyone know what is 2 times 32 is?
64.
64. And now we have to use another property where you need to change the 64 to the power of 4 so that your base and your argument is the same. So can someone tell me 64 is 4 to the power of what? Anyone? 64? 4 to the power of
Is cubed.
this cube. And then what happens to the 4 and the 4 here?
Canceled.
Cancel up. So what you left is a 3. So this is your answer for question number 5 here. So make sure you guys understand this. On top of these 3 properties, there are another 3 more properties that you learned on the previous one, because you will get asked this in your test. Okay. Last one, number 6 here is ln 1 over by square root of e. So we know that ln is a base e, and we have an e over here. So hopefully we might able to cancel, like here, remember the log 4, we can cancel it. But can someone write this in exponents form? Remember last time 1 over 125, you give me 5 to the power of -3. So can someone write 1 over root e in a power form? This is e to the power of what? This is what we did last time in Wednesday. When you have a square root, you can write this in a power form, right? What is the power for a square root? A to the power of, I think I told you guys last week, right? Anyone know how to write this? In the square of a is a to the power of what? Kamal, Henry, Ni. Do I teach you that? Yes, last week. This is power of 1/2, right? Because your index is 2. So any root, you make it as 1 over. So this will be what? A to the power of
1/3.
1/3. So my question to you is, how do you write 1 over square of e? E to the power of
1/2.
1/2. But since it is 1 over, like here 1 over, what happens to this 1/2?
Negative.
Negative. Okay, so make sure you guys understand the square root is 1/2. 1 over make it negative. And then what happens to ln and e? Ln and e, like log 4, they will cancel out. So what you get here is just what? Negative 1/2. So this is the answer for question number 6. So these are something that you guys need to know for this. Like a square root is 1/2, cube root is 1/3. 1/, is negative. Basic exponents rules. So this is how we do this kind of questions on 5.3. Okay. Next we have 7, 8, 9, 10. Here is this time we want to expand. So these are the keywords you're looking for. So expand means you read your properties from left to right. Okay. So we will do question number 7. This is not too bad. Actually, you take longer time to type this in your homework or take longer time to write this than doing this. So can someone tell me what is the expansion of this when you divide? Avery, Nee, Henry? Not Lukin and Kelvin, because you guys know it. Henry, can you tell me what is the expansion of when you expand log y over 2? Hello? Oh, someone chat something. Yep, very good, Henry. So that would be correct. Log y minus log 2. Okay. Make sure the base are the same because they're all same base 10. Thank you so much, Henry. It's easy, right? It's not that difficult. So for question 8, we got ln z minus 1 square. Again, we want to expand. What kind of, last time is division, we subtract. What kind of operation do you see on this case? Avery, what kind of operation you see here? Addition, multiply?
Multiplication.
So what is the, you're correct. So what you do when you multiply? We
Would be the
add.
product.
So we're gonna add them. So what you get when you add this, when you expand this? Avery?
Z plus or ln z plus 1.
ln z plus ln z minus 1, and this z minus 1 is power of what? Power 2. Now my question is, can we distribute this ln into the z minus 1? Can we do this?
No.
No, because we don't have such property. Remember, I highlight this in purple or blue. We don't have this, so do not distribute this, you get it wrong. But we got something else to do with this 2. What can we do with this 2? Remember the third property, the power property says if you have a power, what you do with the power, you bring him to the front. So what happens with this 2? You bring into the front. This 2 will be gone. Okay, you bring the 2 up front, and that is your answer in this case. So your answer in this case will be ln z plus 2 ln z minus 1. For your online homework, I just want to point out to you guys, make sure you put parentheses on your argument. Like here, make sure you put parentheses around them. If you don't put parentheses around your argument, they will mark you wrong. Okay, and if they mark you wrong because you forget to put the parentheses around those, the z or the y or the 2, please send me an email and I will give you back the correct points. Okay, so yep. So those people who, now I'm telling you now, so if you get this wrong, the reason why you get it wrong is not because you did wrong, it's just you forget to put parentheses around the y, the 2, the z. So yes, constantly I have students asking me that. And if you did it, just send me an email. If you don't want to redo your work again, I will give you back the points back as long as it's a correct answer. Now, As you mentioned, as you know that there are two terms inside this argument, two terms. So you got two terms. This one you got two, you got two. Can someone tell me how many terms you see on this question 9 here? Anyone? Terms? How many terms? How many terms you get for question 9? We will get 3 terms. One is for the x, one is for the y, and one is for the z. Now again, there is a square root. You have to write this square root in power form. Can someone write this in the power form? Can someone write this in a power form? So the x4 is still x4 because the square root doesn't have it. And can you tell me where should we put x4? On the top or on the bottom?
The top.
The top, because it's over 1. So this is on the top. Now the y is also on the top because on the. So can you tell me what y power here in this case? The z is on the bottom. Y will be not 3. So there is a power 5 here. So that is another property that I need to show you. Last time I told you square root of a is a to the power of 1/2, right? This is what we did last time. So what happens if this one is a5? Then this is actually 5/2. So when you guys do the if you have a power on the variables, that power goes to the top of the fraction. Okay. So can someone tell me what is this y will be? Power
5/2.
Okay. So this will be 5/2 because the power is 5, but the root is 2. And z in this case is power what? 1/2. And what we're gonna do here, class, is we have to expand this 3 terms. Since this 2 is multiply means, do we add or do we subtract?
Add.
And this is divide, we have to subtract. Right? So in this case, we will have log 2 x to the 4 plus log 2 y to the 5/2 minus log 2 z to the 1/2. So this 2 is multiply, we add. This is division, we subtract. And as the last thing we do, the orange one, what we do here is if they all have powers, where do the powers goes? To the front, right? So your answer in this case will be what? 4 log 2x plus 5/2 log 2y minus 1/2 log 2z. You guys all right here?
Yep.
Questions? And as usual, in my test, I'm okay with this, but in your homework, make sure you put what? Parentheses on those x, y, z. Okay, I think they will mark you wrong if you don't put that parentheses. So last time you got this on the top, so we add them. So now if you look at question number 10, put parentheses on it. X squared, y squared, and z cubed. So again, we got 3 terms here because we got x, y, z variables. So we're gonna write this as log 5 x squared. Now, because this is a division, so division like last time is a subtraction, so we will subtract this log 5 y2, And don't forget, z cubed is also a division because you're dividing. So this you will subtract again. Log 5 z3. So what is the difference you see here is if they are on the top, they are positive. Okay, if they are on the bottom, they are negative. So the properties of log is always that way. Is if you want to expand the log, if they are on top, they are positive. If they are the bottom, they are negative. That is the property. That's the quotient and the product property says. Okay, and the last thing we do is the powers. So you got all these powers you see here. What do we do is you just make them up front. So this is a 2 log 5x minus 2 log 5y and minus 3 log 5z. And in your online homework, give them parentheses here. You guys doing all right here? Anyone have any questions for me on this one? And in my test, what do I say? What do I use this as an instruction? Expand. Okay, so make sure you read the instruction carefully. Expand is the one that I'm using here. Okay, and now we're gonna do the opposite one, which is condense. Okay, so we are condensing here. So can someone tell me how do we condense number 11? Just doing backwards, that's what we did last time. Do you remember what happens if you have a number in front?
Is it log 2x squared plus log 2y
Yep.
y to the power 4?
Yep, so we move it back. You are correct, Sanukin. So we just do it backwards. So if you have a number in front, we move it back to the power. And now we have an addition. So how do we condense this into one log? We should have a parenthesis. We're gonna do with these two arguments here. Are we multiplying? Or are we dividing?
Multiplying?
So because it's addition, so your answer will be x squared and y4. So this is how we condense this into single log. You guys doing all right? I want you guys go ahead and try number 12. Log x minus 2 log y plus 3 log z. And don't forget what I told you. If they are positive, we go put up in the top. If they are negative, we put them in the bottom. So go ahead and condense number 12. It's not tough. This is the work for this section is actually easy. Anyone got an answer for this?
Log x times log x over y times, log x times z to the power of 3 over 2 over y2. Sorry.
Y squared. Yep. Yep. No, can you find? I got what you mean. So it's log x to the times z3 because x and your z is a positive. So that's why you put it on the top. We move the 3 up there. That's why you got the z3. And then the y square will be on the bottom because it is negative. So this is correct. Yep. Not tough, right? Pretty straightforward type. And for number 13, what you need to do first is the 4 that you see there. Now that 4, we can distribute it. Yes, this one, we can distribute it. That is correct. Okay, so it's a number. Number we can distribute, but not log. Okay, so when you distribute this, you will get 4 ln z plus 4 ln z plus 5 minus 2 ln z minus 5. So I just distribute the 4. So can someone condense this into one single ln? Again, positive goes to the top, negative goes to the bottom. Anyone?
ln z to the power of 4 plus z. No, sorry, that's multiplication. So z plus 5 to the power of 4 and all over z minus 5 to the power of 2.
Very good. This is correct. Okay, so the z to the 4 plus means multiply z to the 5 to the power of 4 over by z minus 5 squared. And don't FOIL it out. Please don't spend your time foiling power 4 and power 2 here. And class, you cannot cancel here. The reason why is because these two are not the same common factor. So this will be your answer in this case. And make sure you put a big parenthesis on this. So pretty easy, right? Not that tough. This is pretty, I can tell you that this is easy, but the application is coming out, which is on next section 5.4. When we solve this, we want to write this in a condense it into single log. So make sure you guys understand how you do condense. Expand, we seldom expand, but condensing, we use it a lot. So in 5.4, we use this a lot. We want to condense this into one single log. So make sure you guys understand how to do that. The last thing we're going to talk about here in 5.3 is I give you 3 log. It's given you that log B2 is around 0.363562. And then log B3 is around this number 0.5646. And then log B5 is around 0.8271. And the question number 14 is asking us to figure out what is log B45. Now, how do we do this kind of question is we want to make this number 45 by using 2, 3, or 5, the multiples or the divisions. So can someone tell me what times what is 45?
22.5.
Someone say something. Kelvin? What times what is 45? Now, a lot of students use 9 times 5. 5 is good because 5 is here, but 9, can we still break down 9?
Yes.
Become what?
3 times 3 times 5.
So, yep. And the reason why we use those is because the 3 is here and the 5 is here. So, so we try to use these numbers. So that's why we don't use 9 and 5. We do 3 times 3 times 5. Now, as you learned this just now, you want to expand this. So if they are multiplying, what you do? Add. So we got log B3 plus log B3 plus log B5. This is the, because we got multiplying, so you're going to add them. And since the question provide to us log B3 is this, so this is 0.5646. And this is also 0.5646 because it is B3. And then B5 is 0.8271. I cannot even read my handwriting. Yep, 8271. This is 2. So 0.827. So what you need to do, class, is take out your calculator and add these numbers up. So go ahead and add the number up, and whatever you get, that is your answer. You guys okay here? Questions for me? Anyone got an answer when you add these numbers up?
$1.956.
Now, do not round your answer here. So whatever you get,
3 then.
3. Yeah, make sure you have that. So please don't round your answer. I think same thing happens in your online homework. Put whatever the answer, don't round it. Okay, do not round it. Now, next is question number 15. We have log b root 2. We can write something with the root 2. What can we do with this root 2?
So 2 to the power of 1/2.
Yes, you're correct. And we have a formula or a property with this 1/2. What can we do with this 1/2?
Put it in front.
Put it up front, yes. Remember, any number to the power, you can always put it up front as long as a log in front. So in this case, this is half of log b. Do we know what is log b is? Log b2 is? Log b2 is what?
0.5362.
0.3562, right? This one, right? Sorry for my bad handwriting. So what you need to do for this question is you just take your calculator and do what? Half of 0.3562. Again, no rounding. What's your answer in this case? Zero point 17 something. Hmm? 81, something like that.
Yeah, 8-1.
So again, very not too difficult. I want you guys to try to do question 16 now on your own. Yep, try to do your question 16. These kind of questions I will ask in your test 2 next Wednesday. So make sure you guys know how to do this kind. It's not that difficult, right? So make sure you guys know how to apply this. You know, using the 2 and 3 and 5.
I think I got 16.
6. Okay. So how do you do this?
Is it log b 3 plus log b b and plus another log b b?
Or you can do that. Yep, log bb. You can do log bb square. Or you can do plus another log bb. It's fine. Yep, that's correct, Nukin. And what is log b3 is?
0.5646.
0.5646. And what is log bb is? This one come from here.
1.
1, yes. So don't forget that bb is a power 1, so that's why you get 1. And you get another log bb, you add another 1. So what is your answer in this case? .5646, right? Okay. So you can either do it this way, or if you want, you can put this as log bb2, and log bb2, the bb log bb will cancel. So what you get is 2 here. So they're the same thing. So I'm not very picky how you do this. As long as your answer is correct, I'll take it. Does anyone have any questions for me on this one? Can you guys do this in my test? So my question is, I want you guys to do this now. Using the same thing, log b2 is this, log b3 is that, and log b5 is that. I want you to do what is log b let's do 9/4. So using the same thing, I want you guys to do log B 9/4 is, what is this? Go ahead and try to do it your own. Again, I like to ask these kind of questions in your second test, which is next Wednesday, not Monday, it's on Wednesday. You need a calculator, very basic calculator. Yep, that will be your attendance. So I want you guys to go ahead and don't type present. I don't want to see present. I want you guys to do this question and see what you get. If you get it wrong, it's fine. At least as you try, should be very similar to. No, you try. Oh. Ni is wrong. 4168. Where's my calculator? I don't have it with me. I have it now. Anyone? Well, I got different answers now. I got 1.8416. I got 0.16. Oh, I got different numbers here. Oh my God. 84. Who is the correct one? I got so many different answers. Suksa, that will be wrong. All of them is wrong, Suksa. Nukin is correct. Henry is correct. Ni is wrong. I don't know where she got that from. Oh, Ni came from 14. How about Avery and Gamal? 0.1912. No. That is. Okay, these kind of questions will be asked in your test. So Henry, since you get it correct, and also Nukin also get it correct, can you tell me how you get your answer here?
Log B is, so it would be log B3 plus log B3 minus log B2 minus log B2.
Yes, that is correct. The reason why the log B3 are positive is because it's on the ups here, so that's why these three are positive. And the reason why the twos are negative is because it's in the denominator. And the reason why we got this is because 3 times 3 is 9 and 2 times 2 is 4. So then you just substitute all this inside here, right? This is 0.5646 plus the same thing, 0.5646. And then minus these two. And then you will get 0.4 something, 4168. You guys all right here? Questions? Questions here? So it's not difficult for this section. So we're gonna move. We got some time, so we're gonna move on to the next section here. Before I move on to the next section here, your online homework due on this coming Wednesday is 5.5 to 5.3. So this is 5.2 that we're going over here. It's pretty much simple, and then I will continue with 5.4 here. So what is 5.4? 5.4 is where you begin to solve exponents and log equations. Okay, so this is where you solve equations here. So there are two basic strategy that you solve basic exponent equation here. One is using the one-to-one property. Now, one-to-one property is used if you can make them the same base. Okay, so one-to-one property is used if you make them the same base. For example, in this case is ax is equals to ay, then x equals to y. So as long as your base is the same, then your exponents will be equal. Same thing with the log. If they are the same, log ax equals to log ay. So as long as your base is the same, your argument is going to be the same, x equals to y too. So this is the same, this is what we call as a one-to-one property. This is really, really rare. So we don't do this a lot. We do this, but it's really, really, really rare. And it's very difficult to get them the same base, okay? If they have not the same base, then we use the inverse property. And what is inverse property is you move your base. Remember on 5.2, I teach you how to change from log to exponents and exponents to log by moving your base. So that is used when your base is different base, okay? So what do I mean here when I say move the base in this case is, for example, is ax equals to y. So if I want you to move the base, I move the a over there. So x in this case will be log ay. So we move the base. Or if you want, we can move the base of a back here. So this is the meaning of moving the base, where you guys use the inverse property. Okay, this is what we use a lot in this class. Okay, in this session. And that is this is one thing. And then there's another thing is checking your answer. Okay. Now, as you remember that when you guys do exponents, all your exponents, the graph looks something like that or like this, the exponents graph. Your domain in this case is always all real numbers. So when you guys do the exponents equation, you checking here is going to be optional. The reason why is because your domain is all real numbers. It means all your x values will work. However, if you do the log function, now if you remember log function looks something like this, the graph. Your domain here is not all real numbers. Anyone remember what is the log function here? What's the domain? Let me talk about this. Anyone know what's the domain for a log function or ln function? lnx or log x? I'll redraw the graph for you here. What's the domain here? What number we cannot put inside here, inside this argument?
Negative number?
And also what? 0, right? So the only number you can put in is positive. So the domain in this case will be from 0 to infinity. So that's the reason why that when you guys solve a log equation, checking in this case is required. The reason why you're checking for the log equation is required is because we want to check if there is any extraneous solution here. So for the log, so you have to check for extraneous solution. So what is extraneous solution means that if you got your negative, if you plug into your argument and this number came out to be negative or 0, that solution is extraneous, means it's not going to be good, it's not checked. Okay, so this is only work when you have log equations or ln equations, you have to check it. So make sure you guys know this. This is very, very important because a lot of students forget to check these equations and they won't get full points. Okay, and how do you check it? Is plug it back into this and see if the number is positive. If your number is positive in the argument, means you're good. If your number here is not positive, it's extraneous, means you have to reject your answer here. So those are the little stuff that you need to watch out for. So so we look at some examples here. Okay. This example want us to they want us to solve this equation. Use our, if you put in the decimals in round it to 3 decimal places. So question 1 is asking us to do 1/2 x equals to 32. So what we do here is we have to move your base. So do you guys remember how you move your base here? Anyone? X is equals to what? Not log of what? 1/2 to the 32, right? Now, do you guys remember how you do this in your calculator? We use change of base. So what's the change of base in this case? Anyone know how to use a change of base here? That's the first thing you learned in my class today. Anyone? Change of base? Log what over log what here? Andrew? Yeah.
10/5.
I'm sorry?
32,
Never mind.
Log 32 over log what?
1/2.
1/2. What is that? Use your calculator. Gamal say something just now. Gamal, what did you say? Yes.
No, I said something wrong.
What you get? Take out your calculator.
5.
5. Was that 5? Or -5? Hello?
I got -5.
Yeah, it should be -5, right? Class, yeah, it should be -5. So again, what you do here is if you have an exponent, we move the base, become log, and then use the property of log, like change of base, product, quotient, power rules, and then use a calculator to divide it. Do we need to check this answer? Checking the first one is optional, and the reason why I say the first one is optional checking is because this is an exponent. You can, if you want to check, you can plug -5 in there in your calculator. You take 1/2 to the power of -5. You should get back what? 32.
So that answer wouldn't be extraneous?
No. The answer will not be extraneous because this is an exponent equation. Exponents equations work for every answer. So this is actually check. Okay. If you have a log equations, then you have to check it for extraneous. But if you have an exponents, all answers check. Gamal, you got what I'm trying to say?
Yeah.
Okay, so for exponents, no matter it's negative, positive, 0, or check. You can check it. Plug in your calculator, half to the power of -5, you get 32. You should get 32. Okay, so make sure you guys know that. Log, you have to check your answer. Exponents, you do not need to. Okay. So how we do question 2? Remember, we move the base. So what you do here? Log 5x to the half. Where's your base in this case?
5.
5. So we move the base here. So what you get? This is
Log 5, 1/2.
So log is disappeared. So what you get? X is equals to what?
5,
To the power of
1/2.
1/2. Do you guys know what is this is? The same thing as the square root of 5, right? Anyone has a calculator? What is root 5 is? Anyone?
Two 2.236.
This question won 3 decimal place, 2 point something, right? 3. Right, square root of 5. You guys got calculator, you should know. 2.236. Yep, thank you. 2.236. Now my next question is, do you need to check this answer?
Yes.
Yes, and it's very easy to check. You just take this number, the answer you get, plug it into your X here because it's a log. That's why you need to check for extraneous because it's a log equation. Is this number when you plug in here, are they positive? That's what we need to check. Is this number positive or not? And since this number you plug in is a positive, this will be checked. If this number came out to be negative 2.236, and when you plug it into here, this will what? This is extraneous. So this is how we check your answer here is depends on what you have. If this number is negative, when you plug it here, become negative, you will reject this answer. Then your answer will be no solution. Okay, your answer will be no solution. However, if this like the one that we get here is positive 2.236, it is checking nicely, so that one is checked. So usually what I'm going to tell you guys here is when you want to check something else, make sure that this number is positive. If that number you plug in here is positive, it will be checked. Okay, that's how we do checking in this case. Right, let's try number 4 here. Number 3, 4 times 3x. Anyone have any questions for me? That's the last question we'll do here. Equals to 2.
When you're checking number 2 and you plug in that number in for x, do you do the change of base thing?
Yes, if you really want to, yeah. If you really want to check if it's correct, you have to use a change of base. And your answer will be a little bit off. It's not going to be exactly half because we round this number. So you get very close to the half. Number 3. So how do we solve question 3? 4, 3x equals to 20. Can we move the base like what we did in number 1 here? Oh, move this 3 over. Can we do that in this case? The answer is no, you cannot do that. It's because of the 4. Okay, so you can only move your base if you got just exponent by itself. You see this number 1? So if you got an exponent by itself, then you move the base. So in this case, before we move the base over, we want to get rid of this 4. And how do we get rid of this 4? Like solving equation, we're going to divide both sides by 4. So now what we have is 3x, in this case is 5. So this is always the first step we do if the exponents has something multiplied or added to it. You have to make the exponents by itself. And then after that, we move the base. So anyone know what is this will be?
Log 3 to the
So-
fifth power.
So it's log 3, 5. And you have to use change of base, right?
Yep.
So what's the change of base here?
1.464.
So it's log 5 over log 3. 1 point gamma
464.
464. Do we need to check this answer?
No.
It's optional. If you want to do it, you just plug 1.464 in here and then take 3 to the power of 8 times 4. You should get 20. Very close to 20. Okay, because again, you round your answer here. So again, it's optional. And the reason why this is checking is optional is because this is an exponent equation here. So make sure you guys know a little bit about this. It's not that tough, right? This is not that tough. So we will continue the rest of this on Wednesday. So this is where you solve equations here. So very important. And on the next section after this is going to be all word problems like this. And when you solve word problems, you have to make the word problem become an exponents or a log equations, and then you have to solve it. So we will definitely continue this on on Wednesday class in this case. Okay, so we're gonna end today's class here. Does anyone have any questions for me? I think you guys did type something. I think Gamal is the one that is missing. Do you type something on the chat room, Gamal?
No, I didn't.
Can you
Sorry.
type something in the chat room, please? Like present. I think the rest of you did type something, I believe. Yep. All right, so I'm gonna stop the sharing here. So so this is the end. Please start working on your homework because and then your test is coming up soon. So Wednesday. So if you have any questions, please email me. And I will get my review done by hopefully by tomorrow or Wednesday, and you will get the review for the test too. Okay. Anyone have any questions for me before we end the Zoom class today?
No.
Stop.